Okay, hi everyone, welcome to this video series on Windows Server 2000. So I just want to go share screen, entire screen, and hopefully you can see this. So chapter 4 of Windows Server 2000 Architecture Overview, Understanding the Foundations of Windows 2000 Server Core System. The architecture of Windows 2000 Server represented one of the most significant technological leaps in Microsoft's operating system history. Building upon the base established by Windows NT, it introduced a robust, modular, and secure architecture that enabled it to compete with Unix-based enterprise systems. In this chapter, we'll explore the inner workings of Windows 2000, examining how its components interact to deliver stability, scalability, and extensibility. 4.1 Core Architecture Model. Windows 2000 Server is built upon a hybrid kernel architecture, a design that incorporates elements of both microkernel and monolithic kernel philosophies. This hybrid approach enables performance optimizations while still performing modularity and stability. Key architecture layers: 1. User mode. 2. Kernel mode. Each mode has specific responsibility and hosts critical subsystems that interact with hardware and applications. 4.2 User mode. User mode is where applications and some systems processes run. Processes in this space have restricted access to system resources and must rely on APIs to interact with hardware or the OS kernel. Key user mode components: Win32 subsystem, CSRSX.exe provides the standard Windows API for user applications. It is responsible for console, Windows shutdown, and GUI support. Environment support allowed the system to support different APIs. Windows 2000 includes Win32 primary POSIX for Unix compatibility. OS/2 limited support mainly for console applications. Integral subsystems communicate with executive services in kernel mode through a tightly controlled interface. User applications and user processes interact with system libraries like kernel32.dll, user32.dll, GDI32.dll, which pass requests to the system call interface for kernel mode handling. 4.3 Kernel mode. Kernel mode has unrestricted access to system memory and hardware. It hosts the OS core services, including memory management, process scheduling, I/O control, and device drivers. Components of kernel: executive services. The core functionality layer between hardware and applications include Object Manager, unified object-based resource management, files, devices, threads, etc. Process Manager handles thread creation, scheduling, and process lifecycle. Memory Manager controls virtual memory, paging, and caching. Security Reference Monitor (SRM) enforces security policies and permissions. I/O Manager manages communication between drivers and I/O requests. Local Procedure Call (LPC) handles communication between processes. 2. Kernel. This low-level core the low-level core responsible for thread scheduling, interrupt dispatching, and hardware abstraction. It operates below the executive layer. 3. Hardware extraction layer. The HAL abstracts physical hardware from the kernel and drivers. It ensures portability across different hardware platforms by translating OS instructions into hardware-specific operations. 4.4 Windows Driver Module (WDM), introduced in Windows 98 and adopted by Windows 2000. The Windows Driver Model standardizes how device drivers interact with the OS. WDM improves driver compatibility across Windows versions, power management, plug and play, PnP support, unified driver architecture, kernel mode drivers, user mode drivers. WDM consists of layered drivers that use IRPs, IO request packets to communicate. NTFS 5.0. Windows 2000 introduced NTFS version 5.0, which included major improvements over previous file systems. This quotas an encryption file system, EFS, sparse files and repair points, journaling for file access consistency, file-grained access, ACLs, access control lists. Other supported file systems include FAT, FAT32, though they lack NTFS advanced features. 4.6 networking architecture. Windows 2000 included a redesigned TCP IP stack that was fully 32-bit and integrated with DNS client server, dynamic host configuration protocol DHCP, Windows Internet Name Service, WINS, routing and remote access service RRAS, IPsec VPN support, QoS, quality of service. This robust networking layer allowed Windows 2000 to function as a modern internet-facing server suitable for both intranet and extranet deployment. 4.7 security model. Windows 2000 adopted a role-based multi-layered security model centered around authentication and authorization. Kerberos v5, default protocol for domain authentication supporting mutual authentication and delegation. LTM retained for backward compatibility. Security Accounts Manager, SAM, manages user local accounts. Active Directory stores domain, users, groups, and security principals. Security identifiers, SIDs. Every object, user, group, machine is identified by an SID. Permissions are granted via access control entries, ACEs, in access control lists, ACLs. Security policies and auditing. System policies enforced via group policy objects, GPOs, event viewer logs, security events for audits. User rights can be delegated or restricted via local security policy. 4.8 service architecture. Services in Windows 2000 are managed by the Service Control Manager, SCM. Launches services during boot, manages service dependencies, controls service start, stop, pause operations. Examples of core services: service description, lsass.exe, local security authority subsystem, winlogon, manages user logins, svchost.exe, hosts multiple services, spooler, manages print job, IIS, admin, service controls, internet information services. The Windows, 4.9, the registry system configuration database. The Windows registry is a hierarchical database used for storing, configuring files. Major hives include HKey local machine, HKLM, HKey current user, HKCU, HK users, HKey classes, root, HKey current config. Registry edits can alter driver settings, user preferences, and security policies, but improper changes can destabilize the system. 4.10 System Process Overview. A few essential processes that run at all time. Process role system, kernel and device drivers, smss.exe, session manager, csrss.exe, client server run time subsystem, winlogon.exe, manages logons and control alt delete, services.exe, starts stop system services, ls.ass.exe, handles authentication policies. Understanding these processes helps in monitoring system health and troubleshooting issues. 4.11 comparison with NT 4.0 and later systems feature. NT 4.0 Windows 2000 and Windows Server 2003 Active Directory, Kerberos authentication, group policy, plug and play support, limited moderate full, NTFS version 4.0, 5.0, 5.1/5.2 plus. Summary. Windows 2000 Service Architecture was a massive step forward by Microsoft, introducing a modern hybrid kernel, full 32-bit memory management, and advanced security and modular services. It brought together the needs of the enterprise and the flexibility of a general-purpose operating system. These innovations laid the groundwork for everything in Windows Server line that followed. In the next chapter, we'll explore Active Directory, the most significant and transformative feature introduced in Windows 2000 Server. So here's just a quick picture here of our Windows Server 2000, our switch and our firewall, and our 20 client computers that will be connected to the Windows Server Active Directory. So thank you for listening to this live stream. I hope you enjoyed, and thank you again.